Yes, please. Great. And in a minute and a half, I'll hit start webinar, and then we'll start the production,
Great.
if you will.
Looking forward to it.
And please note, people will be allowed to raise their hands for questions, as well as putting stuff in the Q&A. And you'll hear me give a little bit of a speech on how they can do that and how they then get unmuted. We unmute them and then they unmute in order to speak.
Okay. And then we are hoping to have the last 10 minutes for Q&A.
Yes, I'm going to tell them that we'll hold the Q&A till the last 10 minutes.
Okay, great.
And hey, I'll monitor the participants for hands and Q&A section, because most of the questions I assume are going to be to the page AI type work. So then I'll be able to ask you those questions.
Okay, that sounds good. I'm going
to
mute
Deep
and
breath.
go grab a
We're
cup of
starting.
water.
All right, sounds good.
Hello, and welcome to Breaking Down Barriers to STEM Learning with AI ML with Hema Natarajan and Charles Lapierre of Benetech. We will begin shortly. Hello, and welcome to Breaking Down Barriers to STEM Learning with AI ML with Hema Natarajan and Charles Lapierre of Benetech. We will begin in about 30 seconds. Hello, and welcome to Breaking Down Barriers to STEM Learning with AI ML with Hema Natarajan, Product Manager, and Charles Lapierre, Principal, Accessibility and Content Quality Architect of Benetech. This is a 30-minute session. I am David Ross of the Site Tech Global team. Before we begin, a couple of housekeeping items. This session is being recorded and will be available on demand in a couple of days after the show on the Site Tech Global website. During the Q&A portion of the breakout, which will begin at around 20 minutes, please use either the Q&A box or the Raise My Hand feature to ask your questions. The hotkeys for raise lower hand on the Mac is Option plus Y, and on Windows, it's Alt plus Y. For those who raise hands, we will be calling your name and activating permission to speak. You will still need to unmute yourself. The hotkeys for unmute on the Mac are Command-Shift-A or on Windows Alt plus A. And without further ado, please take it away, Hema and Charles.
Thank you, David. Hi, everyone. Thanks for joining us today. So we are going to start with a little bit of introduction to Benetech and the work we do. So I'm going to ask Charles, who's been at Benetech for many years, to talk about Benetech and our mission.
Thanks, Hema. Yeah, Benetech is a 501c3 nonprofit company based in the heart of Silicon Valley, founded by Jim Fruchterman in 2000, where actually I was employee number 1. Benetech's mission is to deliver technology, services, and programs to empower the most underserved to learn and pursue their dreams regardless of their ability. Over the past couple decades, Benetech has leveraged tech to make scalable impact in the field of education and digital publishing, as well as prior programs in human rights, the environment, and accessible best practices coming out of our Diagram Center. Bookshare is our flagship initiative funded by the Office of Special Education Programs at the U.S. Department of Education. It's the world's largest collection of accessible books with over 1 million titles in multiple formats like DAISY text and audio, Braille, Microsoft Word, and EPUB. It allows students with reading barriers like dyslexia, visual impairments, and physical disabilities to read in ways that work for them, and is free to U.S. schools and students with qualifying disabilities. And adults also use Bookshare in over 70 countries around the world for work, learning, and leisure, and pay a small annual fee for this unlimited access to books. Bookshare operates under an exception to the copyright law called the Chafee Amendment, which allows us to provide copyright digital books as long as they are available only to persons with a bona fide print disability. Many publishers donate to books to Bookshare, but unfortunately, not all of these books are fully accessible, which leads us to try to improve the quality of these books we receive. Benetech is working with publishers, helping them to make their books accessible with our Global Certified Accessible, or GCA program, which not only guides them through how to make their books accessible, but once they are certified, allows them to stamp their books as GCA compliant, meeting the latest in accessibility standards in the industry. Building upon the success of making text accessible with Bookshare, Benetech began looking at the next frontier, increased access to STEM learning and STEM careers. So let me now ask you a question, Hema. You have been leading our effort to build an AI-based product to solve the STEM accessibility challenge. Tell us more.
Yes, thanks for that question, Charles. As you stated, Benetech brings about 2 decades of expertise leveraging new technology to make reading and learning accessible for people with reading barriers, especially at scale. We are working with students in the US and internationally. But during this phase of making reading accessible and improving the reading fluency of these students, one thing we noticed is their struggle with STEM content. We observed that most of the STEM educational materials are not accessible, and this poses a significant challenge for these students. And it's not only just instructional content, but also assessment content. Like, for example, it's not only just textbooks and study sheets and homework sheets, but also tests and quizzes and other sorts of things like lab reports, right? And as you all know, like STEM is a growing field, and it along with it comes a lot of job opportunities. And I saw one study that STEM jobs are projected to grow by close to 9% per year in the next 20 years, and compared to like 3.7% of growth in other occupations. So we want to make sure that STEM learning is available for all students, and because right now there is a study conducted by US government, I think in the year 2021, that says that students with print disability drop out of STEM by about 8th grade, like at the end of middle school. And there are 10 million students in K-12 grades in the US that have print disability. So that many students are potentially dropping out of STEM because their learning materials are not accessible and they can't really use them comfortably. So and especially when we talk about STEM, it's especially math literacy, it is essential for the 21st century STEM education. So we decided to tackle that challenge of making math accessible. And we built a solution to convert math equations and images into accessible content like text descriptions or MathML. And from that foundation, we have now built a pipeline, a product called Page AI that will convert inaccessible documents into accessible formats to make it easy for educators and other content creators to create accessible STEM documents easily. One thing we have seen, especially during this pandemic timeframe, and a lot of this online switch to, a lot of learning switch to online, is that a lot of educators in K-12 and probably in the higher ed space also do use a lot of teacher-created materials. So we want to help these educators who are creating their own materials for their students to make those materials accessible as well. So our mission really with this product that we're building is to create equity and inclusion in STEM education by bridging the gap in the availability of accessible STEM educational materials. And we have had some great funders like General Motors primarily and Schmidt Futures who are believing in us and helping us build these solutions to address this STEM accessibility challenge. And before I get into the details of the product, I want to first start with talking about what does accessibility in math mean? Like, what is accessible math? And I know, Charles, you have been involved with the advancement of accessible math, and you're part of several different groups that are focused on this effort. So I wanted to see if you can give us some more information about, accessible math and what has been done in that field historically and where it is today.
Absolutely. So there's two main forms of open digital math standards, LaTeX and MathML. LaTeX is primarily used in higher education, great for writing math, but for learning and reading math equations, the web standard MathML is best used. MathML 3.0 is the current version of the MathML standard published by the W3C back in 2014. W3C is the World Wide Web Consortium. The unfortunate problem is that this MathML standard was never fully implemented by all browsers. So we have various degrees of support in the industry. Some browsers like Firefox and Safari have limited support and can render the MathML, but others like Edge and Chrome currently don't have any MathML support. Due to this lack of support natively in browsers, Volker Sorge and the MathJax consortium put forth a JavaScript solution that can be included into the web page that will render the MathML. This also allows the MathML to look correct visually in the browser and can be made accessible to assistive technologies, thus allowing screen readers to get a text description of the entire equation, as well as allow the user to explore the various parts of an equation at their own pace. The latest version of MathJax 4.0 is currently in beta and is expected to be released in Q1 of next year. Another recent development in the accessible math is work done by Neil Seufer, who has created a product called MathCat, which translates MathML into speech and Braille, synchronized speech highlighting, advanced navigation, and support for both Nemeth and UEB Braille, which are two of the main ways math can be represented in Braille. Igalia has been working on a native Chrome implementation for MathML. This work is currently in beta and is expected to be released in the next version of Chrome. This is very important as most EPUB reading systems use Chromium as their rendering engine, which will finally have native MathML support. And coincidentally, Edge is Chromium based, so this will be advancement for Edge as well. MathJax or MathCat will still be required to add in assistive technology, getting access to the underlying text of the visually rendered math equations. And the final piece to the puzzle is work being done, also being done and led by Neil Seufer in the W3C with the advancement of the MathML 4.0 core specification, which is about to go into candidate recommendation status and planned release of late next year. This will be the first major update to the MathML spec since 3.0 was released over 8 years ago now. So, Hema, I know that we've been building a solution to convert math images and equations to MathML. Can you talk a bit about what we did?
Yeah, so we built this product called Math Detective. As I said, we started looking into solving this STEM accessibility challenge, and the first and the most pervasive STEM content is math. So we looked at math and did some research on how math is included in these textbooks and other books that come to us from publishers and other sources. We built this product called Math Detective, which basically takes in individual math components like, whether it's your equations as images or, other mathematical images like shapes or tables or, anything like that. Or it can be your text-based math equations like inline ASCII math. We handle both of these, and we convert these into MathML or spoken text description for the content creator to include in their books. So basically we have two different APIs. One is for image processing and the other is for text processing. And the output options are MathML or text description. We also provide confidence rating for the output, so that the user who's taking in either the MathML or the text description can set a threshold above which they'll accept these conversions. This Math Detective product is currently integrated with Bookshare, and we have been processing millions of equations the past couple of years to include in our math textbooks that are part of our Bookshare collection to benefit our users. While, when I talk about math and the various math components, it's important to talk about graphs because, that's one of the biggest challenges when it comes to math is making graphs accessible. And we are looking into that now. With support from Schmidt Futures, we are leading a project to improve the accessibility of graphs and charts in the K-12 educational materials. The project will mainly include developing a large open source data set of annotated graphs and charts. And also we plan to run a data science competition to encourage researchers and machine learning developers to look into this problem and maybe come up with a solution. They can design a model to automate classification and data extraction from these graphs. So that's an effort that's ongoing right now. And we do plan to announce the calculus competition soon, maybe after the holidays. So anybody here interested in looking into and trying out a calculus competition, you're welcome to do so. With that, so that was our first step towards the STEM accessibility and making math accessible. And after that, we tried to, based on what we did with Math Detective, which was mainly accepting individual, like for example, individual images or batch processing images, we decided to take it a step further and looking at accepting documents, whole document, right? And we started with image-based PDFs because we have this process at Benetech called Shop and Scan, where individual students request certain books, and our team scans those books and makes them available. And it is done because the contract we have with the publishers for our students. And in that process, when the book is scanned and it's made available, there is right now there is a manual aspect here where, once the book is scanned and it's in a PDF format, it has to be converted to an accessible format, and typically it's EPUB, and that part is done manually by somebody who is doing the OCR and then writing the description and putting that all together. So we decided to build this product because of the success of Math Detective. We built this pipeline where we accept this image-based PDF and then use a segmentation model to segment each image, which is a page is an image in this case, and then segment the page into these different elements. Currently we use like 11 classifiers, and then these elements are processed through different modules. If it's anything math related, it goes through Math Detective. If it is just a text block, then we use a separate text OCR model for it. So it gets processed, all these different components within the page. And then while we are doing that, we also retain the ordering of the page and the elements within the page and all that information. So after the processing is done, we put all that information together. We synthesize XHTML and then put all the the different XHTMLs together and construct the EPUB. So that's a pipeline process. And so right now it works with image-based PDFs, but we are also looking at making it work for text-based PDF. In the future, our plan is to look at using accepting other input formats and also producing other output formats. So when I talk about AI and machine learning, using AI and machine learning to build such products, I think one of the important aspects I should touch upon is the data sets. So we've been training our model with not only private data sets, but also we use publicly available data sets and we plan to just keep building our data set as we make progress in this area. I have to mention, like, we are really grateful for GM support in these, General Motors, who's our funder, their support in these efforts, because with their continued support, we are making great progress towards building Page AI as a product, and in partnership with our end users like educators, university, like DSO offices, and other stakeholders in the inclusive education ecosystem. So we recently actually piloted this with some of our users and got some great feedback, and we are working off of that feedback and trying to make it better. And our hope is that we can launch a beta sometime in the later second half of next year. And we do also plan to integrate this with our Bookshare content ingestion flow so that we within Bookshare are able to make any inaccessible STEM education materials into accessible documents for our students. And then, yeah, like I said, we want to just go beyond math and also maybe look into other STEM subjects like chemistry, biology, and physics. And that's in our roadmap and our plan. Actually, when I talk about other STEM subjects, making other STEM educational materials accessible, I want to focus on chemistry because I know that Benetech did some work through our diagram center on making chemistry accessible. Charles, can you tell us a little bit more about it? Because I know you were involved sort of in that effort too.
Yeah, no, you're right, Hema. The Diagram Center worked on making all kinds of STEM materials accessible, from image descriptions, math charts, tables, and as you mentioned, chemistry. One key partner with the Diagram Center was a professor at the University of Birmingham named Volker Sorge. And in our published EPUB entitled Diagram Reports 2017 through 2020, Volker wrote the chapter on multimodal STEM documents, where he showcased his work on accessible chemistry with an interactive aspirin model, allowing users to navigate the various chemical bonds making up the entire molecule, speaking and highlighting these bonds whilst being explored. There are other forms of chemistry markup being used today, such as ChemML or CML, but nothing has come out as a front runner, and there's limited accessibility support from my understanding. Many EPUB publishers use either images or, hopefully with alt text descriptions, or MathML to represent chemistry equations. When MathML is used, these equations may look nice visually, but assistive technologies, screen readers, must try to infer the meaning when speaking the chemical equation. A solution to this problem is being put forth in the latest MathML 4 specification with a proposed new attribute called intent, where the author can add semantic information about what field this equation is intended to be in. This provides the missing piece that assistive technologies can leverage in order to speak the equation correctly in the context that it was intended. For example, carbon dioxide versus CO subscript 2. And we're running a little bit out of time here. Hema, did you want to discuss the future of Page AI or start answering questions?
Yeah, I can touch upon it just like for a minute, and then maybe we can start answering questions. Like I mentioned, we've just barely scratched the surface of what's possible with AI and ML. We definitely plan to do a lot more in this space, going from not only expanding from math, but even within math, looking at other complex structures and adding contextual awareness and applying that into our descriptions. We want to progressively train the model using complex and diverse data set. There's really sky is the limit here. And in terms of availability of this product, we want to make it available. Like I said, we want to do a beta next year, and then it can, the Page AI product may be available as an API or a subscription-based service. But we want to make sure that this is available for any educated DSS offices, libraries, and other small and large-scale content producers to help create content that is accessible. Because ultimately, our goal with Page AI is to, help make STEM inclusive and bring in all students, just bring in all the students here with whether they have any reading barriers or disabilities or learning differences. We want to make sure that they are able to pursue STEM career without any barriers and succeed outside of, not only in the classroom, but outside of the classroom as well. Yeah, I know that I guess we went too much into our Q&A time, but so yeah, we'll stop here and then we'll open it up for questions now.
It looks like there's two already. One is, can you discuss why MathML is better than LaTeX? Well, they're both used in different contexts. MathML is great for potentially writing math equations, especially if you're used to like a LaTeX editor, but it's very techy. You're talking about backslash, bracket, begin document, end document, so it's really, is very difficult. It's not like a very seamless and easy to use, like, just typing in. So it's really for the low level to get exact math put in, but it's a language in its own. So it's a little bit complicated. So I'll put it that way, where MathML, once it's there, you can, you get a nice seamless begin fraction, numerator, denominator, things of that nature when it's speaking, right? So that's really the main focus here. And then we have a question here from Peter Hayton saying, for Math Detective, do you have any plans to make it available more broadly? For example, allowing students to use it to make inaccessible teacher slideshows accessible?
Yes, so for that particular scenario, I want to say more than Math Detective, which is an API that you have to integrate with your system software, whatever you use. PageAI is a perfect solution, and that's our goal with PageAI is, I forgot to mention about the UI that we are building on top of PageAI, which will make this whole process really easy for anybody who wants to use it. For example, in this case, a student, they can come in, they can upload this, I mean, right now we are accepting slideshows, but let's say they make that slideshow into a PDF, an image-based PDF, they can upload it to PageAI, and then they can get that process and get the output immediately. They can see it. They can. We also have a remediation interface where we want to make it easy for anybody who wants to either add more information or fix the description that they see in that document in the EPUB, or even customize the navigational structure of the EPUB, whatever they want to do. We are building that UI on top of it to make it easier. Yeah, so that definitely is the plan, Peter.
Okay. And then, so anonymous, Braille students using Nemeth to learn a math language already, while LaTeX is inherently linear. It may be valuable to investigate compatibility. Actually, that's exactly what MathJax and MathCat do. Is they understand both, and so they can convert into different the scenarios, and with MathCat, it can then put it into Nemeth Braille, right? So definitely that is already being investigated, and was something that we would obviously support with the use of either MathJax or MathCat. And Kevin Chow, Kevin, welcome.
I think that's a question you can answer.
Yeah,
Charles, about writing and editing math.
Yeah, what solution for writing or editing math? Actually, we had a project to MathShare, right? And that work was done in, and we had some grants to work on that. And we've actually spun that out. Hema, do you remember the name of the company? That I don't know either.
I think it's something Pixel. Yeah, we can, if anybody is interested, we can send that information over to them. Yeah, please reach out to us. Yeah,
I just found that out, that we was able to successfully spin that out to another company that's going to take it over. So, we can send us a message, charlesl@benetech.org, and happy to get that answer for you. And welcome, Kevin. It's been a long time. And I think we're at time, and we're also, that was the last question, I believe. Oh no, there's a couple more that just came in. Brian Thompson, does the output of math detection work in other formats other than HTML, such as PDF?
So when we say output, so we give MathML and spoken text, like text description for your math. So if you don't want to include, if we are using our products, it will be part of XHTML and EPUB. And we do at some point plan to produce PDF outputs as well. But if you are just using Math Detective as the API to get that output format for yourself, the two formats we offer are MathML and text description. So maybe you can, I guess, take that text description and add it to PDF.
Right. And then they're looking for a timeline on PageAI. Anything on that?
Yes. So like I said, so we are looking at beta next year, second half of next year. And if anybody's interested, do let us know. And we will make sure to send that announcement over to you when we launch.
Awesome. David.
Well, that's all we have time for today. Thank you again to our panelists. And as a reminder, this session will be available on demand in a couple of days on the SiteTech Global website. Please return to the SiteTech Global website to catch the latter part of what's next with Stellar Trek on the main stage. So once again, that's it for this webinar. Thank you very much for attending the webinar, and please return to the main stage. And
thank you, everybody.
Thanks, everyone.
Thanks for joining.